folks, on our next video in statistics, and this is our example number 2 as promised in our last video in um, probability and probability distributions. So we're going to consider this example now. So what we're going to find here is we need to find the probability distribution of the sum of the numbers when a pair of dice is rolled. Okay, so that's what we're going to do. Again, our random experiment is when a pair of dice is being rolled, and we're going to get the sum, okay, of those numbers. And then for number 2, we'll be finding the probability that the sum of the numbers is going to be 9, when the sum of the numbers is going to be less than 5, when the sum is greater than 10, and when it is between 6 and 11. Okay, and thirdly, we will find the expected sum of the two numbers in the roll of 2 dice. Okay, so first we need to really establish the sample space of this die, and then we need to get the individual probabilities. We need that in our probability distribution, and also when getting our expected value or expected sum. And also we need that in our number 2. Basically, we need that in everyone. Okay, so first we need to consider the outcomes, all of the outcomes in this certain problem, or this certain random variable. So recall that when we are throwing 2 dice or a die, and this is by default a regular 6-sided die. Okay, so imagine a die to have this cube, and then imagine that the faces of the dice are ranging from 1 to 6, right? So this, for example, this is 1 here. For instance, this is 2 here, and we have 3 here, for example. And we're going to throw 2 of them. Okay, so 2 of them we're going to throw. So we're going to throw another one. Okay, and then we need to consider the sum, okay, of these 2 dice. Okay, when we throw them. So imagine this is 5. For example, we have here, for example, a 1, and we have here, for instance, a 4. So this is just for illustration purposes. Okay. Now, again, throwing 1 die will give us the numbers 1, 2, 3, 4, 5, and 6. This is 1 die. What we're going to do is we need to intertwine that with another die. You can do it like this: 1, 2, 3, 4, 5, and 6. Okay, so what we need to do is get the sum, right? So we need to put it in this notation, or in this positioning, and then we will consider everything. So first, we need to pair up all of this. Okay. For instance, we're going to have it as 1, 1. Okay, that is for the first die, it brings up 1, and then the second die it brings up also 1. So hence, what we have is an ordered pair composed of 1, 1. Here we are going to have a 1, 2, 1 here and 2 here. Here we're going to have a 1, 3, 1 here, 3 here. And then we're going to continue this until we reach 6, 6. Okay? So continue, we have 1, 5. Okay, so this is all of the possible values or possible pairs of values for a sum, or for all the sums, or for pair values rather, when you throw a pair of dice. Okay, first up, so we can see we need to count. Remember, in our probabilities, we need to consider the n of s. The n of s. Okay, so of course, this is just the illustration. We need to establish what is the value of our s. So the value of our s is equal to, we're just going to put that in set notation. So this becomes 1, 1, 1, 1. Also we have 1, 2, we have 1, 3. Okay, and then we end here with 6, 6. So imagine this ellipsis, because if I'm going to write it all, so it's gonna be used to do that. So imagine that all the values of inside this big X will be everything from here. So we counted how many they are. So it's a 6 by 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So we know 6 times 6 is equal to 36. So there are 36 possible outcomes when you throw a pair of dice. Okay, so we will let the X, a random variable, or we will let big X in this example. We'll let big X to be our random variable. So this random variable is equal to the sum, because we're particularly looking for the sum of the numbers. Okay, and what we will do is just to get all the sums. So for instance, X is probably how many do we have? The sum of 1. The sum of 1 and 1 is 2. The sum of 1 and 2 is 3. The sum of 2 and 1 and 3 is 4, and so on. We can think about that in this kind of setting. The sum, since we call the X the sum, so for instance we can call the sum of the numbers 1 and 1. Okay, is equal to 2. The sum of the numbers 1 and 2 is equal to 3. The sum of the numbers 1 and 3 is equal to 4. So again, we are taking into consideration all the sums. Like for example, 1, 1 is 2, 1, 2 is 3, 1, 3 is 4, 1, 4 is 5, and then so on up until 6, 6. So you can see the values that we can have. Okay, let the range space. Okay, we'll call this a range space, or simply the X. The values of X can assume the values of that X can assume the sum of the numbers that X can assume is going to be the set of all possible values of X. So it's equal. Some books call it the range space. So we call this as, okay, we have 2, 3, 4, 5, 6, 7. Okay, so this is the range space for X. So our X, the sum of the numbers, can assume any value from 2 to 12. Okay, so it can assume any values from 2 to 12. So I think it's due time now to create the probability distribution of our X. I need to move it a little bit here, and we'll create the probability distribution here because we'll need these values. So we'll call X to be the random variables. And then we can have the frequency so that we won't get confused. We'll call this F as a frequency, so that we won't get lost. And we'll call this the probability of each of the X's to happen. So this is your P of X. And let's have this as values. The values of our X can assume, or big X can assume, is from 2 to 12. So this becomes, let's write here 2, 3, 4, 8. So we will count how many in this given probability outcomes here. In this outcomes, the list of outcomes, how many have the sum of 2, 3, 4, 5, 6, 7, 8, 9. So for the sum of 2, we can also only see that there's 1 there, so there's only 1. For the sum of 3, we can see 2, 1 and 2, and 2 and 1, so we can see 2. For the sum of 4, we can see 1 and plus 3, 2 plus 2, and then 3 plus 1. That's going to give us 3. For the sum of 5, we can see is 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4. That's going to give us 4. Here, for number 6, what we can see, the sum of 6, 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, and 1 plus 5. They all sum up to 6. So there are 5 of them. For the sum of 7, what we can see is 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 7, 1 plus 6. That's going to give us, there are 6 of them. For number 8, 6 plus 2, 5 plus 3, 4 plus 4, 3 plus 5, and 2 plus 6. That there are 5 of them. And for 9, we have 6 plus 3, 5 plus 4, 4 plus 5, 3 plus 6. That's 4 of them. For 10, 6 plus 4, 5 and 5, and 4 plus 6. There are 3 of them. For 12, 6 and 5, and 5 plus 6. There are 2 of them. And for 12, there's only 6 and 6. There's only 1 of them. So we want to get the total. The total here is there are 36. Right? There are 36. That is the total number of your sample space, which is also denoted here, the end of your essay sample space. Okay, the cardinality for the number of elements in the sample space. So what we're going to do is we're going to get the probabilities for each of them. So how to get the probabilities is we're going to divide 1, or rather these frequencies, over the total n of s. Okay. So how we do this is like this. So we have 1 over 36. Let's write it in this manner so that it can fit. Here we can see 2 over 36. Here we see 3 over 36. Four over 36. Here we go back to 5 over 36. Then we see now that, remember, one of the characteristics of a probability distribution is that the sum should be equal to 1. So let's see if this ends up to become 36 over 36. So we have 1 plus 2 is 3, 2 plus 3 is 5, well, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 20 plus 6 is 21, 21 plus 5 is 26, 26 plus 4 is 30, 30 plus 3 is 33, 33 plus 2 is 35, 35 plus 1 is going to give us 36 over 36. Or this is equal to 1. Okay, of course you can simplify this in any part, but believe me, it's much better if this is not simplified yet. Okay, so we're done with the probability distribution. So voila, this is the probability distribution for our first question. For the next question, we are therefore asked things like this. Okay, so find the probability that the sum of the numbers is 9. So the probability that the sum of the numbers is 9, we will call that, let's call it event A. This event A will mean that the frequency, the sum is 9. So we can say that the frequency or for our small x, one of the values is 9. Okay, so how do we get this? We just simply look at the table. So look at the value of 9. How many? What's the probability of getting 9? So that's going to give us 4 over 36. So we say that the probability of getting the value A, which is getting the value 9, exactly 9, is equal to 4 over 36. So we can simplify this, since this is one of the answers. So 4 over 36 can be simplified as, divided both by 4, this is going to give us 1 over 9. And this is our probability for the frequency for getting the sum, which is equal to 9. So let's box that. That's our answer for number 1. Now how about for number 2? Number 2 asks us what is the probability of getting less than 5. So less than 5, that's strictly less than 5. So what we have is, we're going to first call that let that be. Okay, so we will let that be. So this is equal to the frequency for all x less than 5. So for all x less than 5, we say that this for all x equals 5, this is just simply the numbers less than 5. So this is our 5 here. So what we're going to do is to get into consideration all the numbers in x for 2, 3, and 4. So we say that is x is equal to 2, 3, 4. Okay, now how many are the numbers there? So what's the probability then? So the probability of getting event B, okay, is equal to the probability of getting 2, 3, 4. So we can say that it's the probability of getting the 2 plus the probability of getting the 3 plus the probability of getting the 4. So we substitute the values there. So probability of getting 2 is 1 over 36 plus probability of getting a 3 is 2 over 36. The probability of getting 4 is equal to 3 over 36. So this is the virtue why we do not simplify yet, because addition will be quite easy if the values are not yet simplified. Imagine if they are simplified, we still need to get the LCD and then combine them. So it's like doing what we're going to do here. So 1 plus 2 plus 3 is going to give us 6. The answer is 6 over 36. We can just simply simplify that and divide it by 6. That is, it's going to become 6 divided by 6 is 1. 36 divided by 6 is going to give us 6. So this is the probability of B, or we say B as the frequency of getting, or the sum, which is less than 5. So the answer here is 1 over 6. Okay, so we're done with number 2. Let's proceed to number 3. Number 3 asks us, or letter C rather, the probability of getting a sum which is greater than 10. Greater than 10. So letter number 3, or letter C rather, number 3, we will let C that is, we say that x is greater than 10. So we say that these are the values which is our x is greater than 10, strictly greater than 10, notice. So that is equal to 11 and 12. So our x values are 11 and 12. So let's try to solve for probability of C here. That is, we get into the values of P of 11 and the values of plus P of 12. Okay, and then let's substitute them. This is going to become P of 11 is 2 over 6, or 2 over 36, and the probability of 12 is equal to 1 over 36. 1 over 36. So we combine them. We call this our probability of C again. This is equal to 3 over 36. We can simplify this and make it simplified. We'll divide both of the parts, numerator and denominator, by 3. This is going to give us 1 over 12. 1 over 12. And this is our answer for letter C. Okay. Now for letter D, our last number for this example, what we have is between 6 and 11. So what's the probability between 6 and 11? So between 6 and 11, need to make it down here. So for number 4, getting the sum, which is between 6 and 11. So let D be equal to the sum between 6 and 11. Okay, so since it's between 6 and 11, this is not inclusive. Okay, so this is not inclusive, meaning we just need to consider all the numbers between, okay, 6 and 11. So if this is 6 here and we have 11 here, so this is not inclusive. So what we're going to enter or to input is 7, 8, 9, 10. So that is, again, this is not inclusive. That is, we put into your x are equal to the values which are 7, 8, 9, and 10. So since it's strictly between 6 and 11, so 7, 8, 9, 10. And then to get the value of the value of the probability D, what we need to do is to get the sum of all the probabilities from 7, that is, we can write it as P of 7 plus the P of 8 and we substitute the values of each of these individual probabilities. We see that 7, since I can think it cannot fit, so 7 is 6 over 36, 8 is 5 over 36, 9 is 4 over 36, 10 is 3 over 36. This is going to give us overall 6 plus 5 is 11, 11 plus 4 is 15, 15 plus 3 is 18. So that's going to give us 18 over 36. Simplify that. We divide that both by by 18. These are both divisible by 18. This is gonna give us 1 over 2. Actually, this is 18 times 2. So this is our answer for letter D, for our number 4. Okay, so that's pretty much our answers in number 2, which is we're going to find the probability. Let's proceed in finding the value, the expected value, I mean. So the expected sum of the two numbers is just, remember the formula, is summation of all the x sub i's times the probabilities of that corresponding x sub I. So we're going to look at this table again. Maybe we can fit it here. Okay, what we want to do is to get the expected value or the mean of this probability distribution. So how we do it is like multiplying this x to each corresponding probability. 2 times 1, 6, 3 plus 2 over 6, 4 times 3 over 6, and so on, and then until we get all of the numbers. So I think we need to have some space here. I know where we'll write. Okay, so let's see the expected value. This is for our number 3. So the expected value or expected sum of the two numbers in the roll of the dice. So we call that P of x because that's what we call the expectations of Bx. Okay, it's equal to, we just need to multiply 2 times 1 over 36 plus 3 times 2 over 36 rather, sorry, we need to put 3 here, times 3 over 36. And then we continue this until we got the 12 times 1 over 36. Okay, so I'm going to show you the table again. So this continues up, continue the operation, denoted by the ellipsis here, which is in the center. The last point in the table is well, what we are doing is 1 times 1 over 36, 3 times 2 over 36, 4 times 3 over 36, 5 times 4 over 36, and so on. So we end up with 12 over 1 over 36. So let's do that. Oops, sorry. Oops, sorry, this should be 3. My goodness. So that should be 3. So this will be 4. Should be 4. And then we continue again. Like I said, we stop until we reach. We stop until we reach 12 times 1 over 36. Okay, so imagine that in this ellipsis, what we're doing is continuing the process. So when we continue the process, what we'll have are different types of numbers. We will just multiply all of them. Okay, multiply, get the product of each of them, and then it will give us all the products. And then what we need to do is to get the sum. So if we're going to get thorough with this, actually this will give us 2 times 1 over 36 is 2 over 36. 3 times 2 over 36 is going to give us 6 over 36. 4 times 3 is going to give us 12 over 36. And then 5 times 4 is going to give us 20 over 36. Plus, well, the next one is 6. Let us check here. This is 6 times 5 over 36, 7 times 6 over 36. That's 5. 6 times 5 is going to give us 30 over 36. Over 36. And what we have is, and then we have 6 times 7 is going to give us 42 over 36. So this is 2 times 1, this is 3 times 2, this is 4 times 3, this is 5 times 4, this is 6 times 5, this is 7 times 6, next is 8 times 5, which is plus 40 over 36. Next is 9 times 4, which is 36 over 36, this is 1. Plus, we need to continue that down below, but still not fit. Plus, we're done with 9 over 4. We need to continue with 10 times 3. So it's going to give us 30 over 36. And then what we have is 11 times 2, that's 22 over 36. And lastly, we have 12 times 1, which is 12 over 36. Getting its sum, believe me, you can try in your calculators, but the sum is equal to 252 over 36. We want to simplify that, and this will give us our answer, which is equal to 7. So this 7 is our expected value from this given experiment. Okay, so our answer is equal to 7. Okay, hence, what does it mean for this? It means that on the average, the sum of two numbers in one roll, okay, when you roll a pair of dice, the sum, on the average, the sum that will come up is 7. Okay, so that's our example 2. Okay, so pretty much that's it. Let's go back. Our question is this: probability distributions. Okay, find the probability distribution, find the probability that the sum of numbers are these, and then find the expected sum or expected value. So I'll just going to run you through this. This is our number 1 answer. And then we have it here, the probability distribution. And then our answer in number 2s are all over here. Let's zoom out a bit so that we can see. So these are our answers for number 2. And ultimately for number 3, we can see our answers here, which is equal to 7. Okay, so that's it for this video. Hopefully you learned something from this. And see you soon in the next videos in statistics. Hopefully this helps. So thank you very much.